So, let us discuss something about goodness of fit measure. Goodness of fit measure or R square in qualitative response model. Qualitative response model. Now, you have to keep in mind that the standard interpretation of R square, that means the standard R square interpretation, the R square which we derived earlier in case of linear regression model, classical linear regression model, is no longer applicable in qualitative response model. So, standard R square makes little sense in the context of qualitative response model. Why this is so? Because in the case of linear regression model, what is the R square measure? Let us say this is your xi, this is your yi, and let us say you have this type of scatter plot. And what is the regression line first of all? The regression line alpha hat plus beta hat xi is basically a representation of your data. That means, this is some kind of average line which represents this data point. And what is your R square? Your R square is for any given value of xi, what is your predicted value, what is your observed value. Let us say this is your observed value, okay? And let us say this is my yi bar, right. So, this is my total variation TSS, and out of which I have explained this much. This is yi hat, this is ESS, and this is RSS, and your R square you have defined as ESS by TSS, right. So, out of your total variation in y, which is measured by yi by y summation yi by y bar whole square divided by total variation, and how much you have explained? Summation yi hat minus yi bar, and then your R square is ESS by TSS. So, when you have a scatter plot like this, so that means given xi, your yi can take any value and you have a proper scatter plot and you have a regression line which basically represents the scatter plot. And what is goodness of fit? How good my regression line is in representing this scatter plot, which is nothing but the raw data, right, which is nothing but the raw data. But suppose we are in a context where this scatter plot itself does not exist, then what you will do? That means this regression line itself make little sense. We cannot get this type of a regression line which we will call the average line, average representation of the scatter plot. Then how will you take this RSS ESS by TSS? It does not make any sense. And that is what is happening in the context of qualitative response model. How? Let us see here. This is in this axis, let us say I am measuring xi, and this is yi, and this is 0, this is 1, okay, this is 1. So, that means for any value of x, you are either here or here. That means your probability is here or here, either the event will happen or not happen. Okay. So, either the event will happen or not happen depending on your x value, let us say that is income. Okay. So, that means there is no scatter plot, and if that is the case, if the scatter plot does not exist in the context of qualitative response model, standard R square interpretation also is no longer valid. Okay. So, what I am saying, since there is no proper scatter plot in qualitative response model, I will write QRM. In QRM, standard interpretation of R square is no longer valid, is no longer valid, because I cannot get a line like this, okay? And unless I get that type of regression line, I cannot apply the ESS by TSS formula to get the R square. So, what we need to know, we need to derive alternative measures of R square, okay? Alternative measures of R square. And let us see what type of alternative model we can derive. So, alternative measures of R square, alternative measures of R square in the context of qualitative response model. So, how will you modify this? Let us say that this is R square equals to ESS by TSS, and that we can write as 1 minus RSS by TSS, 1 minus RSS by TSS. Now, in the context of QRM, we need to get some kind of equivalent measure of RSS and TSS. And econometrician, they say that if it is qualitative response model, then your RSS means, RSS basically what? You have incorporated certain explanatory variable and your model is explaining some part of the total variation in Y, and the remaining portion is RSS. In qualitative response model, when you are estimating your coefficient using log likelihood method, what the log likelihood method they do, they go for iteration, several rounds of iteration to maximize different log likelihood functions. So, the first step in that iteration is when you have not incorporated any explanatory variable, and if you do not incorporate any explanatory variable, then you see, if you go to status output, look at how stata is estimating the model. If you put the mfx command, logit command, let us say this is my model. Now see, this is iteration 0, 1, 2, 3, 4, and this is the final. That means 0 means, what is the iteration 0 means? In your log likelihood function, you have no explanatory variable, only intercept, and that is your log likelihood value. And what is iteration 4? You have included all your explanatory variable in the model. Similarly, iteration 1 means 1 explanatory variable, 2 means 2 explanatory variable, 3 explanatory variable, 5, right. So, this is your initial log likelihood value, this is your the final log likelihood value reported here, minus 417.2214. So, out of this 5 explanatory 5 levels of iteration and 5 log likelihood value, something represent your RSS, something represent your TSS, and we need to identify which one should be my TSS and which is my RSS. Obviously, when you have no explanatory variable in the model, there is no question of explaining anything, there is no question of remaining anything. That is the reason the log likelihood corresponding to iteration 0 in stata is reported as L0, okay, L0, and the final one is called L1. So, this is defined as L0 and L1. This is when you have no explanatory variable, that is L0, that means that is your, that time it is L0 and this is L1, okay, this is L1. So, that means this is your RSS, this is TSS. L0 means 0th level of iteration. In terms of status outcome, if you look at what is L0, minus 514.87, minus 514 equals to minus 514.87 or something, divided by sorry, I made a mistake, I think. This is this is L1 is, what is L1? L1 is this. Since both are minus, minus minus will get cancelled, 417.22, 417.22, and then this is 514.87, 514.87. So, this would become your R square. Okay. So, if you calculate this, then you will get your R square. Okay. You will get your R square. And that R square is basically the R square reported here. Look at this. This is called pseudo R square, which is 0.1897, 0.1897, which is called pseudo R square. This is pseudo R square. Okay. So, since the standard measure of R square is not applicable in the context of qualitative response model, econometrician they have derived an alternative measure of R square, which is this ESS by 1 minus L1 divided by L0, where L1 is basically, what is L1? I will specifically write here. L1 is the value of log likelihood when all explanatory variables are included and L1, L0 is value of log likelihood when no explanatory variables are included. No explanatory variable is included. In the model, right. This is one thing you have to keep in mind, which is called pseudo R square. Then another important measure what we need, how do you check overall significance of the model. Overall significance. So, in standard econometric model, what we used to do? We used to do by F statistic. But here we get a different measure. If you estimate the model, and then as I said, you will get L1 and L0, okay, and L0 is the initial value of likelihood, L1 is the final value of likelihood when you include all the variables in your model, right. And if you calculate this 2 into L1 minus L0, then you will get an equivalent measure of F statistic in the context of qualitative response model, that is called log likelihood ratio, okay, LR chi-square or likelihood ratio statistic, and that actually follows a chi-square distribution where degrees of freedom equals to number of explanatory variable in the model. Okay. So, this is also known as LR chi-square. So, log likelihood ratio statistic. So, that means from here what we can calculate is 2 into what is your L1? L1 is minus 417.22 minus L0, and L0 is what? L0 is minus 414. So, this you can put one minus. So, minus and minus it should become plus 514.87. If you calculate this, then that would become your calculated value of chi-square, which is nothing but 195.30. 195.30. This is your calculated chi-square calculated, and again you have to compare this calculated chi-square with the tabulated chi-square at a specific level of significance, and depending on whether this calculated value is lower or higher than the tabulated value, you have to reject or do not reject your null hypothesis, right. And what is your null hypothesis here in the context of overall significance? As we all know, this is basically beta 1 equals to beta 2 equals to beta 3 equals to beta 4 equals to 0. This is the null. So, overall significance of the model you will get by LR chi-square statistic given by Stata. Look at now, this is LR chi-square 195.30 with 4 degrees of freedom, and Stata is also reporting the corresponding p value which is 0.000. That means LR chi-square is highly significant at 1% level, okay, and this shows that your model is overall significant. Alright, and another difference between the standard model and qualitative response model, you look at your how do you measure the significance of individual variable? Instead of t, here we are getting z, okay, here we are getting z. What is z? Basically z, you have to remember that z stat is the large sample counterpart of t, large sample counterpart of t. As I told you earlier that in the context of qualitative response model, in the Logit model, the estimation technique is MLE, maximum likelihood estimation, which requires large sample, because in the large sample only all these desirable properties, that means estimates are asymptotically efficient, they are consistent and efficient at the large sample. That is why MLE requires a large sample, and the large sample counterpart of T is actually the Z statistic. There are other differences of T and Z statistic which probably you can look at. What is the difference between T and Z? This you can look at. Okay. So, what data is reporting is the large sample counterpart of the T to test the individual level significance of the explanatory variable. Okay. So, this is how you can actually estimate the Logit model and you can interpret. Same way, you can estimate the model using another qualitative response model that we have discussed earlier, which is called Probit. So, that means instead of Logit, you can put Probit also. And you will get this, again mfx command if you put, you will get the estimated value. So, now if you compare the Logit and Probit model, look at the coefficient here, education coefficient is 0.10 in the context of Probit, but that was 0.18 in the context of Logit. So, that means the coefficients of Probit model and the coefficients of Logit model, they are not directly comparable. But the question is, the empirical question, how to choose between Logit and Probit? How to choose between Logit and Probit? How to select between Logit and Probit? Okay, Logit and Probit. So, in Logit, once again if you look at what we assume, pi equals to 1 by 1 plus e to the power minus alpha plus beta xi, and in the context of Probit, pi equals to f of alpha plus beta xi, and this f of alpha plus beta xi assumes the cumulative distribution function of the logistic distribution. That means, as we have, what is fi equals to integration minus infinity to alpha plus beta xi, and then alpha plus beta xi f z dz, and z equals to 1 by root 2 pi sigma square into e to the power minus zi square by 2, and this zi equals to zi minus mu by sigma whole square, the standard normal variable. Okay, standard normal variable. Now, both this logistic and both normal and the logistic distribution, they have 0 mean, because here we are assuming standard normal variable. So, mean is 0, but their variance and standard deviation, they are different. So, here the mean is 0 in the context of standard normal variable zi, That means here Zi follows a normal distribution with 0 mean and 1 variance, right. And here this Zi follows in the context of logistic distribution, the mean is again 0, the variance actually pi square by 3, it is not 1. Because of the difference in their variance, here it is 1, here it is pi square by 3, where pi equals to 22 by 7. So, that means here it is sigma equals to pi by root 3 equals to 1.81 or something, 1.81 or something. Okay. So, if you multiply the Probit equation by 1.81, so that means what I can say, that beta hat Probit multiplied by 1.81 equals to beta hat Logit. This first of all you have to check. If you look at your model, what is the Probit estimate? Probit estimate is for a particular variable 0.10, and here it is 0.10, here it is 0.18. So, Probit estimate equals to 0.10 multiplied by 1.81 equals to 0.18. Okay. So, Probit estimate is 0.10, and if you multiply that by 0.181, then you will get the Logit estimate. That is the idea. Okay, that is the idea. Now the question is, how do you select between Probit and Logit model? Now, for most of the cases, this simple diagram will explain which particular this is alpha plus beta xi, here I am measuring pi, and this is 0, this is 1, okay. And it says this is, let us say, the Logit CDF of Logit, and this is CDF of Probit, this is CDF of normal, this is logistic. Or I will say that instead of writing all this, I will say that, let us say this is my Logit and this is Probit. So, that means compared to Probit, Logit has a flatter tail. Okay. What does it mean? That means if there are too many observations at the upper or lower tail, then from the diagram itself it is very clear that if there are too many observations at the tail, upper or lower, then logit is a better representation of that sigmoid S or nonlinear relationship than the probit, because probit is a little short. And in the middle range, both logit and probit are same. Logit equals to probit. Then logit is preferred than probit. Many a times we use logit and probit alternatively, exchangeably, and we think that we may use either logit or probit, it does not matter. But the question is, what is your data set? If in your sample you see, for example, in the car owner or house owner relationship, if you sample says that there are 90% individuals who are actually having car, that means you are at the upper end, or there are only 10% people who are having car, you are at the lower end. That situation is better captured by logit model, not the probit one. But if your data says around 50%, 50-50, 40-60 or 45-55, something like that, that means actually you are in the middle range. Okay, you have equal number of zeros and ones, and then we can say that logit is equivalent to probit. Most of the cases we are actually in the middle range. We are actually in the middle range. That is why we use logit or probit alternatively, but actually that is not the case. Actually that is not the case. If your sample says that you have too many observations in the tail, either upper or lower, then you must use logit model, not the probit one. That is why we need to know this type of diagrammatic representation to know which one to select between logit and probit, right? Okay, logit is preferred than probit, that is what we say. In the middle, they are equivalent. They are equivalent. Okay. So, with this we are basically closing our discussion on logit and probit. In our next class we will discuss another qualitative response model. Thank you.